Okay, anybody have any questions about that? Yes?
If you had clean water, would there be some hydrogen ions?
Always, yeah. Because water naturally will dissociate a small amount. Remember, the Kw is 10 to the negative 14. It's a real tiny amount. But it does. Yep. Okay, I'm going to skip that and skip that. We talked about all that. We did that one yesterday. Remember that? Doing a base in water and what's the pH? Okay, now I warned you this is where we were going to start today, but I got sidetracked a little bit in my little panic that we needed to make sure we understood everything. You'll run into problems where you're asked to rank the strength of bases. Which is the weakest base of those four things up to which is the strongest base. They all are being considered in the context of being a base. Can you tell from these four which one is the worst base for sure? That's right. It's the chloride ion. Chloride ion is a terrible base. It is worthless as a base. A base, remember, what's the base's job? To take a hydrogen, to receive hydrogen. Chloride ion, it's never, ever, ever getting back together with hydrogen. Yes? Yeah. Keep that in your mind. I think that's a great analogy of what strong acids do. They break the hydrogen off, and it cannot take a hydrogen. So this stinks if it wants to be a base. There's one other thing. I don't think that I showed you this before, so I want to do it right now. When you have... I have it on some slide, but we haven't seen it yet. I can show this mathematically, but I don't have time, so I'm just going to tell you. The Ka of any acid, weak acid, times the Kb of its conjugate base is always equal to Kw. It's actually a very simple derivation, but I'm just not going to take the time. So this is something that's real nice to know. The Ka of any acid times the Kb of its conjugate base is always equal to Kw. Now we'll do, right after this one, we'll do an example of a problem in which we'll need to use this again. But we'll have to use that here. A few of you have your books with you today. If you have your book, would you take it out? Now, I don't need everybody to look at it, but I would, just ask that you grab your book if you have it. Elaine, I know you have yours. Anybody, JD, did you grab for yours? Yeah. Okay. Go to the acid acid strength table, page 822. If we want to know which is the weakest of the, well, we already know which one is the weakest, and you're right. Cl negative is the weakest of these four bases. How do we rank the other ones, though? Does anybody have a suggestion? How would you know which would be the next strongest and which of these four is the strongest? Is there something that we could use to compare? Carol?
Use the acid, K of the acid, and whichever one has the biggest K of the acid. I don't know, use it to determine Kb from Kw.
Yeah, that's what we're going to have to do. Yeah. These are all being considered as bases. So we've learned that the strength of acids is determined by the Ka value. If you're comparing two things, if one has a higher Ka, then it's a stronger acid than the other. Yes? The same is true for bases. The strength of bases is indicated by the Kb. So if we can figure out the Kb values, just like what Carol is saying, we'll have to use the Ka values of some of these. Now, I showed you this on page A23. If you have your book, look at page A23. Come on. Elena, you can represent. What's common to all the bases on page A23? A23 has the Kb table. What's common to all of them?
They all have nitrogen.
Yeah, they all have nitrogen in them. They're all organic things. They're all amine compounds. JD, you with me on that? Okay. Now, not all of these are amines, so we can't really use that Kb table. It would be nice if we just had a Kb table and told us the Kb of each of these four things. We'd go from lowest to highest, we'd be done. Well, it's not that easy. We do have Ka values, so let's go go ahead and figure this out by looking at what the acids are. So for the cyanide ion, its acid is HCN. Elena, what is the Ka of HCN? It's toward the bottom.
6.2 times 10 to the negative 10.
Thank you. Okay, so HCN as an acid has that Ka value. What about HCl? What's the Ka of HCl? Strong acid.
Oh.
Ka. Products over reactants. 100% dissociation. Better.
1.0.
Even better. Infinity. The Ka is infinity for a strong acid. Yeah? Because remember, Ka is products over reactants. You don't have any reactants. It's like the limit is 0.
Wow.
It's like going to 0.
Wow.
Yes?
The limit does not exist.
I know, we don't like that 0 in the denominator, do we?
No, it's a
mean
mean
girls
girls
thing.
thing.
Oh.
Do you have a daughter?
Do you
Yes.
Have you never watched Mean Girls?
I have. It's been a long time, though.
That's so iconic.
It's a
Yeah, it is good. I like it.
Iconic.
Okay, so anyway, the Ka of HCl is infinity. Sorry that our brains now are thinking things other than chemistry. What about water? Now, water is kind of a stinker in this one, and I'll tell you why. Because we learned, I'm just going to take a side trip. We learned that H2O breaks up into hydrogen ions and hydroxide ions. And we have also learned that the Kw for this reaction is hydrogen times hydroxide, which is 1 times 10 to the negative 14. Water is releasing hydrogen from itself. There's a hydrogen coming off of the water. Could you consider water then, by its definition, to be an acid because it's releasing a hydrogen?
Yes.
You kind of could, yeah. Would you be able to consider water to be a base because it's releasing a hydroxide? Yes. Okay, this part you're not going to like. I'm sorry that I have to tell you this because you don't like it. I don't do stuff that you don't like on purpose to make you not like it. The Ka of water is, because it's releasing hydrogen, is 10 to the negative 14th. The Kb of water, because it's releasing hydroxide, is 1 times 10 to the negative 14th. Do you like that?
No.
No, I knew you wouldn't like it.
I like
Wait, but
It's the same number.
Yeah, it's the same number. But it contradicts this, doesn't it? For every other thing, Ka of any acid times Kb of any base, or its conjugate base equals Kw, except for water. Water is like the foundational thing, and water's Ka is its Kb, which is 10 to the negative 14th. So this is the one thing, species, substance, that violates that Ka times Kb equals Kw. Yes?
So what about what's it called? The thing we just HSO CO3. Like, didn't you say that? Because that can, you said that can also act as an acid or a base.
Mhm.
Would their Ka and their Kb be different?
Yes. They would. Come on. There it is. This is a base, and this is its conjugate acid. So we can look up the Ka of H2CO3. Elena, what is the Ka of H2CO3? It's on the next page on the right. See it at the top?
Just the first one?
Yeah.
4.3 times 10 to the negative 7.
Now, this thing is acting as an acid. What is its Ka? That would be Ka2 of H2CO3.
5.6 times 10 to the negative 11.
See, these don't have the same Ka value. This is an acid in this reaction. This is an acid in that reaction. Over here, it's acting as a base. So the answer to that is you don't multiply that by itself because they're not in the same reaction together. Unlike what's happening here. These are in the same reaction together.
Okay.
Anyway, the answer is if it's amphoteric, it depends on what the substance that's amphoteric is doing. If it's acting as a base or as an acid, it's going to have a different K value. It will. It will. And I think as you go through and you work and think about acids and bases, that will be very clear.
Oh, okay, so, okay.
It is. It is. And I think in your mind you're trying to overgeneralize and it's becoming complicated. It's not. All right, so we're back to this. So that means that Ka of water is 1 times 10 to the negative 14. Okay, now let's go to the HClO2. Elena, sorry, I'm going to ask J-Deep so he doesn't feel left out. J-Deep, what is... J-Deep! What is the Ka of HClO2? Toward the top of the Kas.
1.2 times 10 to the negative 2.
1.2 times 10 to the negative 2. So HClO2 is a pretty strong acid. It's got a real high K value. Okay, now these are the Kas of the acids. We want to know how strong these are as bases. Well, to figure out how strong they are as bases, let's find their Kbs. And I know if you're really good at math, then I'm kind of wasting time. I'm wasting your time, the people who are really good at math, because you're seeing this, and we'll talk about why I'm wasting your time in a moment. But let's find the Kb values of these so that we can rank them and be done with the problem. Kw divided by this is what? It'll be the Kb. Can you give it to me? With a calculation? On your calculator? Please? Oh, Kw, this number, 1 times 10 to the negative 14th divided by Ka. Look, that's what I'm doing. I'm solving for Kb every time. Solving for this. So take Kw divided by the Ka. So 1 times 10 to the negative 14th divided by this.
1.6 times 10 to the negative 5th.
Thank you. Okay, so that's our Kb for cyanide ion. What is the chloride? It would be Kw divided by infinity, which is what? 0. The Kb of chloride ion is 0. A big goose egg. What is Kb of water? Good. Did somebody say 1? Nabil? Okay, okay. That's exactly right. Is that what you meant to say? Okay. Okay, now what about the chlorites ion? Kw, which is 10 to the negative 14 divided by that number.
Times 10 to the negative 12.
3.3?
Yeah.
Thanks. Okay, so we have Kb values for these bases, and we've done what we set out to do. We now can rank them from the lowest value to the highest value, and we've answered the question. So, by rank, this is the worst. I'll call that 1 worst. What is the second worst? The second lowest Kb value? It's the water. Yep, yep. So that's the 2. And what's the third? Now we're getting stronger. The ClO2 is third, and the strongest base is the cyanide ion. The best base of these, best at taking a hydrogen, is the cyanide ion. Now I mentioned that going through and doing this calculation was a waste of time. Why? My math smarties. Carol?
The last one got very different.
Oh, what'd you get?
8.3 times 10 to the negative 15.
For this one?
Yeah.
Nathan,
Oh, I
did you?
got 2.
Yeah, I think I plugged.
Okay. It was 8.3 times 10 to the negative 13?
He's smarter than all of us here, right?
Thanks. Nathan, what happened?
I probably plugged in something wrong.
Yeah, okay. All right, so, yeah, now that didn't change our situation. It's still the third best base of the given 4. Now, my original question was, why was it a waste of time to calculate the KBs for the math smarties? Emily?
Because the higher the Ka, the lower the Kb.
That's right. Yeah, yeah. The higher the, I'll just say it like this. The stronger an acid, the weaker its conjugate base.